Hi guys, Mrs. Cerami again. This is second part of 9.1. Normally we would have covered 9.1 probably in one day in our class, but because it's online, I will be splitting into 3 days. We're going to start with the quote today. Seek the Lord and His strength, seek His presence continually. So just pray for health and strength for all. We're going to do a quick review from Friday from the counting principle, and then we're going to talk about how we're going to use permutations today and when to use that versus counting principle. So from Friday, at a blood drive, blood can be labeled one of 4 types: A, B, or O, one of 2 Rh factors, positive or negative, and one of 2 genders, female or male. How many different ways can blood be labeled? Note that we have different things that we're comparing, different. So therefore, we're using the counting principle. So again, we are going to draw our blanks. So this is going to be for the type. This is going to be for the Rh factor. And this is going to be for the gender. And again, just so you guys know, Amazon told me I will be getting my new board by Monday night. Woohoo! All right, we have 4 types. We have 2 Rh factors, and we have 2 genders. Multiply all the options together, and we're going to get 16 possibilities. The digits 0, 1, 2, 3, and 4 are used to generate 4-digit customer codes. How many different codes are possible if it can be repeated? So again, we have 4-digit. 1, 2, 3, 4. 4 different digits. We have 1, 2, 3, 4, 5 possibilities here. And once we use a number, it can be repeated. So we have 5 options for each. So the number of possibilities would be 625. Again, I'm going a little faster because this is a review. Now this cannot be repeated. We still have 4 different options. We have 5 numbers to choose from, then 4, then 3, and then 2. So when we multiply these possibilities together, we're restricted, so now we're left with 120 possibilities. All right, that's a review. So now what we're going to do is we're going to go on and we're going to talk about what happens when you're comparing one item. Now, before we do that, because we're going to be using a formula, we're going to quickly review what a factorial is. The definition of a factorial is the product of an integer and all the integers below it. Now, it says integers, but I actually like to use the definition of natural numbers. Okay, so I really don't care for that definition. I use natural numbers because we know integers can be negative. Natural numbers stop at 1. So the exclamation in math means factorial. It means you're taking this integer 4 and you're multiplying it times all the natural numbers below it, 4, 3, 2, and 1. So 4 factorial is equivalent to 24. And now we're going to do 12 factorial. Once you try if you want to look for factorial on your calculator, you're going to go to math, arrow over all the way, go to probability, and then select number 4, which is the exclamation factorial, or you can go to catalog. Because you don't want to type in 12 all the way down to 1. So again, you're going to go to math, you're going to go to probability, and then you're going to go to number 4, which is the factorial. So 12 factorial is going to give us a product. Sorry guys, my son was just dancing. Of 4, 7, 9, 0, 0, 1, 6, 0, 0. So in real math terms, once we put the commas in, 479,001,600. Now, we're going to use that in a little bit with the formulas. we're going to talk about permutations. Permutations today means order matters. P, permutations, P, position. If you have a specific position, order matters. So definition and arrangement of objects with order being important. Such as a phone number or a license plate. For example, 973-222-2227 is different than if we put the 7 elsewhere. Since a permutation is the number of ways you can arrange objects, it will always be a whole number. So if I ask what is the permutation, please don't give me a fraction or a decimal. Don't even give me a negative number. It's the number of times. Many times, problems ask for permutations of n objects taken at r at a time. N objects taken r at a time. So this means that you may have 5 objects, but we want to take 3 of them. We're going to explain what that means in a little bit. This is the formula we will be using for it, which again, I'll explain in a little bit. And then I'll also show you a different way of doing it using the counting principle with permutations. I'll model that as well. So permutations, we're going to start with and without a calculator. We'll do both. So this is n items. This is how many items we have in our group. So if there are 5 people who received A's and I have 3 Jolly Ranchers, we want to know how many ways can the individuals get the different Jolly Ranchers. So this is the number that we're choosing from, and this is how many we choose. So this is my N, and this is my R. And I know this is all a review from Algebra 2, but if you have any questions, of course, you can message me. So this is going to translate to n factorial in the numerator, so 5 factorial in the numerator, over the difference of n minus r, so 5 minus 3 factorial. Okay, so without a calculator, we could write this as 5 times 4 times 3, and again, I'm still using my trackpad, so bear with me with my writing, times 1. And this is going to be 2 factorial, so 2 times 1. Well, we can cancel out, well, 1s we don't really need to, but the 2 and the 1. So my product is going to be 5 times 4 times 3, which is 60. Okay, 10 choose 2 would be 10 factorial in your numerator. The difference, which is going to be 8 factorial in your denominator. And again, if you were to write this out, 10, 9, 8, 7, etc., over 8 times 7 all the way down, etc., you'll find from 8 down will cancel out and you're left with 90. Now, how do we do this with a calculator? With a calculator, you're going to go to math. Actually, before we go to math, you're going to first put in your n in your calculator. So you'll put 10 on your main screen, and then you're going to go to math. You're going to go to probability. And you're going to arrow down to number 2, which is NPR. So again, this says probability. This will be neater in a few days. And then in your main screen, it will look like 10 NPR. Type in 2, hit enter, and you come up with this. And I know that your Algebra 2 teachers showed this to you, so I'm just reviewing it with you. But again, any questions on this, you can certainly message me. Okay, so how do we use this? That's the question. A company advertises 2 high school job openings, one for a stock boy and one for a cashier. If 4 people who are qualified for either position apply, in how many ways can the openings be filled? So you need to decide what is your N, what's your group you're choosing from, and what is your R, how many do you need? So my N, we're choosing from 4 people who are qualified, and my R are the 2 positions that are available. So in the calculator, you can put in 4 in your main screen. Then you're going to type in go to math, probability, NPR. and type in 2. Once you type that in, you're going to get an answer of 12. So feel free to use your calculator for the permutations and combinations. For the SAT, ACT, you're permitted to. So I would permit you to on my test as well. Next problem. The ski club with 10 members is to choose 3 officers, captain, co-captain, and secretary. And how many different ways can these offices be filled? Okay. So my N would be 10. We choose from 10. My R would be 3. I have 3 positions, and these positions matter. Matters if you're a captain, co-captain, and secretary. So positions matter. It's a permutation. How many different ways? So in your calculator, you would do 10, and then press the NPR, then go to 3. And you can pause all of this, guys, to see if you could do this on your own. Okay. When you put that in your calc, you'll get 720. I have a bunch more slides here with more problems here for you guys. And what I'll do is I'll write the answers down, and then you could feel free to check it on your own. I don't think everyone here is going to need all these explanations because this is a review. But again, if you have any questions on how I'm getting this, anytime, as you guys have been doing, message me. So this would be 120. Now this is a little bit different. Find the number of distinguishable permutations of the letters in the word tree. So we want to know how many ways can we use those letters to create different words. And the problem is we have 2 E's. So T-R-E-E, and if we switch the E's, you're going to get the same word. So we want to know how many different permutations can we get. So what I did here was I wrote out all the different options here. Let's see if I can move this up. All right. You can see all the different options right here. Because E's are duplicated, we're restricted with the number of options, so we can't do 4P4. Okay, we can't do 4P4 because it's going to give us too many options, because E and E together would give us the same solution. So if we did 4P4, just to show you what we would get 24 options. But when I listed all the options down here, we have 12. So what you're going to do when you have the letters and they repeat, you look at the number of letters that repeat and you divide by that factorial. So you're going to divide the normal permutations. We have 4 letters and we want to choose 4. Divide by 2 factorial. So the number of options that we're going to have will be 12. So this is probably the hardest problem you'll get from me with permutations, is finding how many distinguishable permutations of the letters. So you're going to do the normal 4P4. If there's 5 letters, 5P5, and divide by how many factorial. Next slide. I think this is a little cut off for you guys. Let's see. This says you want to find how many permutations of the letters in the word goggles. So we have 1, 2, 3, 4, 5, 6, 7 letters. So we have 7 letters and we need to use all of them. So it's 7P7. But we have a repeat here. The G repeats 3 times. So we're going to divide by 3 factorial. So 7P7 would give us 5,040. 3 factorial gives us 6. So our final answer is going to be 840 options, which I'm sure you're okay with me not writing out all those options here. You will see this on my math lab. And again, this will be the hardest problem that you will get for permutation. I just find this to be a fun problem. I think if you're doing permutations,